Here is the answer for day 4, problem 1. Solve the matrix equation using the method of multiplying by the inverse. If we want to get the letter A alone, then we need to remove this matrix. And we know from algebra this year that you can remove something that's multiplied to a variable by multiplying by its inverse. So let's find the inverse of this matrix. In finding the inverse, we need to know its determinant. 1 times 3 is 3, subtract 2 times 2 is 4, that's -1. So we have 1 over -1 times, then switch the positions of the 3 and the 1 and change the signs of these two numbers. Now distribute this -1 out front to each of those terms. -3, 2, 2, -1. Here's our inverse. Next step, we're going to multiply by this matrix on the left side of both members of the equation. So we have -3, 2, 2, -1 being multiplied to the left side of this. And on the right member of our original equation, we want to multiply on its left side. The reason for making sure that you write the matrix -3, 2, 2, -1 on the left side of this, and you write it on the left side of this, is because, as we showed as we were working through the homework, multiplication of matrices is not commutative. If this is really the inverse of this, and you multiply them together, they will cancel away, and you'll get the letter A alone. On the right side, when multiplying a 2 by 2 to a 2 by 2, the answer that you get is a 2 by 2. Let's figure out the entries. -3 times 0 is 0, plus 2 times -1, that makes -2. -3 times 1 is -3, plus 2 times 2 is 4, and that makes 1. 2 times 0 is 0, plus -1 times -1 makes 1. 2 times 1 is 2, plus -1 times 2, which is -2. This is 0. We have solved for our unknown matrix A by multiplying both sides of the original equation by the inverse of this coefficient matrix. Now, day 4, problem 2. Rewrite the system as a matrix equation, but do not solve it. Let's create a matrix with the coefficients from the left side of this system. It's 1 and 2 from here and here, and then the next row it's 1 and 3 from here and here. Now we're going to multiply it by a variable matrix, x and y, and that will be equal to the constants matrix containing 5 and 7. We're told that we don't have to solve this, but think about how you would solve it using the technique in the previous question. You could figure out what the inverse of this matrix is, and then multiply on the left side by that inverse, and multiply on the left side of the 5 over 7 matrix. That would make this cancel away, getting the letter x and y alone. And on the right side, we would have the answers for x and y. The point is, you can solve systems of algebra equations using matrices. Now, it's not necessarily any faster to do it by hand using matrices, but since modern calculators allow you to enter matrices, it might be faster to solve systems of equations using matrices if you typed them in a calculator.